G'day ice cream lovers, my name's Steve Christensen, the ice cream bloke and self-appointed headmaster here down at Scoop School, and you know what today is? Yes, Whiteboard Wednesday, Whiteboard Wednesday, Whiteboard Wednesday. Very excited about Whiteboard Wednesday down here at the Scoop School facility. Very excited to also have as a sponsor of this video, Stan, Laura and the whole crew at Green Mountain Flavors. The link is down below. I really shouldn't need to talk about it by now. You're very well aware of Stan and the crew making all natural flavors, all natural colors, all natural extracts. A great resource for your ice cream making. Green Mountain Flavors. Check them out down below. Never, and I repeat, never has one man asked so many times for an answer to a question as Nate. Nate has been basically putting a question on every single video we post about tying two water-cooled units to the same line. Nate, this one goes out to you. So it may sound like a very simple thing to take a water-cooled machine. So let's say we have one water-cooled machine here. Let's say it's a soft serve machine, and fit another one beside it, which is also a water-cooled machine, and have a water line come here and basically what they call T-junction out, so one water goes one way, one water goes the other way. Not so simple, and we're going to get down in the weeds in this session of Scoop School. Talk a little bit about equipment, how it operates. Sometimes it's not as simple as what you might think. Okay, so this T-junctioning of water lines actually happens quite often, particularly if you've got, so let's say, a water-cooled batch freezer that has a water line coming in, and inside the unit you might have a T-junction here which goes off to a faucet, so you can pull a faucet out of the top and rinse it down. That T-junction allows the water to both go to the compressor as well as up to the spigot. Now, that works okay within a particular unit, but if you are looking at putting two units together on the one water line, it can be a little bit more complicated. Now, a lot of people think that it's just down to water pressure. I just need the right amount of pressure here to run two machines, but not that simple, because many of these units run on a specification called a British Thermal Unit, or BTU. And it basically measures the output in heat from a particular refrigeration process, whether it be air-cooled or water-cooled. At the end of this process, it's putting out heat, and that heat is a British Thermal Unit. We're not talking about PSI here, we're talking about how much water do I need in order to turn over that amount of BTUs, and as a general rule, you need 5 gallons of water per hour to produce 1,000 BTUs. So you need to have 5 gallons of water going to this particular unit per hour in order to generate 1,000 BTUs. So then we reverse engineer this and figure out how many BTUs are given, or this unit is giving out every hour. So let's say, for example, this water-cooled soft serve machine, a generic water-cooled soft serve machine is pumping out around about 9,500, or let's say 10,000 BTUs per hour. And this is where you've got to go back to your spec sheets, talk to the manufacturer and ask them how many BTUs is this unit producing per hour, because if we reverse engineer that equation, if we've got to produce 10, or if this unit is going to produce 10,000 BTUs per hour, and again as a general rule, I've got 5 gallons producing 1,000 BTUs. In this case, I'm transferring this down to be, this will be 10,000 BTUs, that's what this unit does. So we'll times this by 10, and now I need 50 gallons per hour of water to basically run this machine. It sounds complicated. You would think, well, just give me a PSI and a pressure, I can check the pressure. It's not always that simple. Now, if you've got a situation where you've got two soft serve machines here and each are producing 10,000 BTUs, then if we did the calculation, we need 50 gallons of water per hour to this unit and 50 gallons of water per hour to this unit, and if your flow in your spigot or your faucet or your water supply can give you 100 gallons an hour, then you should be fine. Now, the good thing is that many of the water-cooled units, if they're not getting the requisite water that they need in order to run effectively, they just will shut themselves down. So there's always some fail-safe that you're not going to damage the unit because there's not enough water going to it. But again, it's quite a complicated process of talking to the manufacturer, asking them what the BTU output is of each of these machines, and we're talking soft serve machines where we primarily could be talking frozen custom machines, batch freezers, shake machines, and figure out exactly how much water you're going to need in order to generate that amount of BTUs. I do tell people that under certain circumstances it is advantageous to run water-cooled equipment, but the industry is kind of moving away from water-cooled equipment now and going to self-contained air. That being said, there are a lot of single-phase water-cooled soft serve machines on the market because that was the collaboration of choice for many frozen yogurt stores. So don't think that you can just buy a couple of these on the cheap, plug them in, and hopefully you've got the right water. Go back to the manufacturer, find out what the BTUs are per unit, and then get an idea of your flow rate in the water to see if that works. Nate, I don't know whether that answers your question, but they are the cold, hard facts. So that's Whiteboard Wednesday for you, everybody. Big announcement tomorrow. The winner of the 10,000 subscriber YouTube competition is being announced tomorrow. So tune into this channel tomorrow, see if you were the big winner of the 10,000 YouTube subscriber mega extract pack. Very, very excited about that. Excited about the vibe and the excitement on the channel. Thank you for tuning in. Thank you for Green Mountain Flavors for sponsoring this video. And look, if you would like to have a question answered like Nate did, he may not be happy with the answer, but he got an answer nonetheless. Then drop us a line, info@scoopschool.com, or just leave a comment down below. We read them all, we try and respond to them all, and from Madeline, Frank, Chip, myself, and all the crew down here at Scoop School, keep on scooping. We'll see you in the next video.